also during the last weeks. Today, we are going to be looking a little bit more into statistics. We're going to be introducing the concept of statistics. We are going to be working on different statistical methods. I'm going to present you some of the basics that you are going to be needed in order to understand other more complex models like, I don't know, like or statistical constructs or tools, linear regression, binomial regression, statistical testation, R-square, and so on. So what I want you to do is just to so you have to be familiar with a couple of things, especially your best friend, which is going to be the mean, the average, the expected value. You can identify it. You can identify what is the role of the errors, how to work with them. And we are going to be looking into some things that you probably already know and maybe explore things related to concepts that you already know. We are going to be using the statistical concepts as building blocks, right? Okay, first of all, you might be asking yourself, why statistics? Well, statistics is at the core of the beginning of a data science project, okay? It's the first step you need to take into account. It's the first step that you need to do. If you're looking into data science, everything that it is related to the application of machine learning, deep learning, or whatever other tool, artificial intelligence model, in order to solve a specific problem to a specific data, well, what you are doing is data science. You are doing some kind of data mining analysis. And the first thing is that you have the reality. We already have been talking about the reality and things that are real, that things are not real. It depends, of course, on how do we characterize reality. It's like a reality at the end for us, people working with data, is like a map. Everything that it is not on the map doesn't exist. So if you are looking into information in Google Maps about a specific location, if it is not on the map, it doesn't exist. Doesn't mean that it doesn't exist on reality, but you cannot access it, you cannot go to that place, you cannot ask Google to go to that place. When you're looking to a database, or you're trying to create a model, a specific phenomena, everything that you cannot measure is something that doesn't exist for you, you cannot take it into account, at least that you generate some kind of indicators, proxies, whatever. The first thing is, you have to decide which data do you want to collect. This is the raw data collected. It is not data collected, it is raw data. Raw data, you know already you can create features out of data. We are going to be looking into that today also, how to create new features out of data, and then you have to process the data. Data processing, working with data, you already know SQL and all these things. You are connected to a database, or someone is providing you with a matrix. You have live data, you might have not live data, whatever kind of data. It has to be transformed and put it in a kind of system that you can access to. It has to be on a specific format. And you have to decide which format are you going to be providing to the data, and that will have an impact on your results. And this is something I want to explain to you today, that in the moment where you just started to decide what is on my data and what is not going to be on my data, then you are introducing a bias. You are introducing a bias as a computer scientist expert on artificial intelligence. You have to be aware of that. Once you start to modify that data, you are introducing more bias. I'm talking about bias here, just defining how your subjective understanding of the phenomenon and your limitations regarding computer power, capability to access to the data, hardware, whatever, is affecting the outcome. Do you understand? So it is not hasn't to be negative in the sense of, okay, we have a problem or whatever. It can be also very positive because you can measure things that other people cannot see or cannot even express by themselves with words. Yes? Then we are going to be having a clean data set, and then we start with exploratory data. And that will be, let's say, the first moment in which you are going to be working with the data set that you have generated and try to understand what is going on, what do I see, what patterns I can identify on my data set, what are the things that might be interesting, and then you start to build hypotheses. Of course, you already have hypotheses when you start collecting data. But here you are going to see if you have to refine your hypotheses, things that you have not taken into account, you are going to be looking into the data from different perspectives. And this is where exploratory data analysis is going to be playing a big role. Of course, you afterwards apply your models and your algorithms, but 90% of the work or 80% of the work, it is on going from the reality to your data sets. And of course, this is an iterative step, let's say. So the 3 steps: cleaning data set, getting the data again, trying to get more data, better data, is something that you are going to be doing, okay, until you get some kind of results that you can use. Or you get results that you cannot use, and then you say to your client, I'm sorry, with this data, it's not working. I cannot do anything. If we are looking into definition of statistics, there are many different ones, okay? Of course, you can define it in very formal terms. It's a branch of mathematics or whatever. I don't like this kind of definitions because I cannot remember them. I prefer to talk about the statistics as something like the way of transforming numbers into or bits into information. I'm talking about information, something that is telling me something. It is not knowledge still, okay? For that, I do need a model. I cannot say much, but I still see something, okay? So I'm changing from bits to information. This is what the statistics is going to be doing for us, or we are going to be doing for with the statistics. So most of the clients that you are going to have on the future, or people that you are going to be working for, they actually have a problem, and is that they have to decide to make a decision, and they don't know how to do it. So you are the expert in order to help them to make decisions. And what are you going to be using? Statistics, which is the art of making decisions when there is some kind of uncertainty. So we still don't know what to do, or it is not clear what to do, or what is going on. It is going to be helping us on how to collect data efficiently, and they are going to be provide us to both generate questions and answers to those questions. So this is why statistics is or has been applied for, I don't know, centuries already, and was developed at the beginning. So if we are looking into Peng, you probably have heard about him, a professor in Stanford. He has a nice book on statistics, exploratory data analysis, that we are going to be using during this course on R. He's working on R, like me. And he in his book on exploratory data analysis, he's providing us the data one more time and visualizing it in order to find out if the models are working or not. And this is really like, if you like computers and you like statistics or machine learning, and you are not really into logic, or you are not really into developing APIs and so on, this is what is gonna. This is a lot of fun already. I mean, you can specialize on this thing and make a lot of money if your goal is to make money, but you can also make very interesting things that are very, very helpful, actually. So this interesting fact about the statistics is that statistics has been used and developed by researchers. So people working in universities, mathematicians, and so on. So we usually use statistics, or have been using statistics, in order to understand better the world. So in order to gather knowledge. So turn that information into knowledge. Okay, and this is what we are going to do by modeling. I have here some terms. I want just you to understand them. Statistics will be then to all the procedures that you need as a researcher, as an expert, okay, in order to organizing, analyzing the data, okay, the information that it is collected. So you have to go from the data to the information, and then apply statistics on them while doing research. And data is all this set of scores, all the set of all the set of collected raw data, okay, that you are going to be transforming, using, modeling, in order to perform your analysis, right? Population is just the reality, okay? And usually we don't get access to the population. So if you, let me give you an example. Let's say that we have access to a company that has data on all his users. Is that the population? or the population are all the potential users, all the people that might be interested, including those that are already that are not on the database. Yeah, it depends probably on the research question, but probably what they want to understand it is what kind of users do they have and what are the characteristics of the users based on a sample, which is the persons that have already buy the product, right? So this is the entire group of persons, individuals, goods, services, whatever. And what we have is the sample. The sample is that piece of that database, that data, that piece of data that we are going to be using. Of course, while we are looking at the data, the sample that we have, we are going to make some assumptions about the reality. The more data we have, probably the more our sample looks like the population, but it is not always the case. And what we have to do is, based on a sample, make assumptions about the population. And this is you making decisions already. How to do sampling? It is part of statistics. So how to conduct sampling, it is also very relevant. And what we usually want to have is some kind of random sampling. So you don't want to work with the whole data set because it's going to be probably very time-consuming, and it will also require specific hardware. What you want to have is some kind of randomness. Okay? Something that doesn't follow any pattern that you can identify. If we will have a person walking, we'll call it a random walk. And random walk is the term that we usually use for sequences of data. It's a walk that it is random, it goes nowhere. Do you understand the term? Well, now let's say that you are paid by a company, whatever it is. Last time my practicant was working for a company, it was AutoScout. You know AutoScout, you want to buy a car and then you go there and then you try to find out. You can imagine they have a big data set on users, on users from the both sides. So the one that wants to buy and the user that it is putting inside the car. But they also have data on people watching without even contacting or having an account. So you have all this data, right? The first thing that you need to do is start with the descriptive analysis. Okay? Descriptive analysis, descriptive study. So you want to see what is relevant. What is the research question that you have? It is not good if in the future your project manager is asking you, okay, we have to look at this, look at the data, this is the database. You want to say, no, stop, sit here with me. What exactly do you want to look at? The data set is too big. We have to define this better so that I can understand how do I start looking, what I'm looking for, what is the problem at hand, right? And then we are going to be doing some descriptive analysis. Why it is interesting, the descriptive analysis? It's going to be helping me find patterns. It's going to be very easy also for me by means of visualization methods to provide the client or the audience with information about things that I have seen. Why are we going to be using visualization methods? Very easy. Because our brain likes things that we can see and apprehend with our eyes more than things we need to read. Because if reading, it involves another part of your brain. Looking, watching, it involves less resources, and therefore our brain can identify patterns much easier. We are going to be looking into visualization methods at the end of the course. Once you have already identified patterns, you already know which variables are relevant and so on. Next thing that you want to do is start to think in a structure, the whole structure, and what are the interdependencies that you might be looking into different variables. You don't want to look only to one variable at the same time, okay? You want to look into commonalities, yes? Patterns that you can see in different columns. Let's say if you have a table, a data frame, things that you can see and you can observe for the whole structure of the dataset. So that you can start formulating hypotheses that might be relevant for you. You can have a main hypothesis, you can have secondary hypotheses, and so on. And once you have this hypothesis, you go and you test them. Okay, inferential. You try to inference, try to find out if the phenomenon that you are looking and you think that it's happening, it's going on, it is really contained on that data or not. Do you understand? Okay, now do this exercise if you have understand this, please. You have to read the scenario below and then fill in the blanks with the appropriate statistical terminology. I have provided you now with some concepts. You have been taking notes, and now you should be able to follow the blanks, to fill the blank. So for A, the entire 120 employees are referred as the population. The B, sample. The procedure used to make sure that the selected participants were representative of the company it's called is called sampling. It's a sample, taking a sample, sampling, and randomized sampling will be the best way of doing it. The values that the researcher obtained from the sample are called what? Data. Raw data. The researcher will use the values obtained from the sample to make predictions about the overall sleep patterns of the company employees. Predicting population characteristics in such a manner involves the use of models, statistics, assumptions, hypotheses. In all likelihood, the values obtained from the selected employees will not predict with complete accuracy the overall sleep patterns of the company employees due to an error. An error, exactly, due to sampling error, due to model error, due to the fact, and as I told you before, is that we have a sample, okay, and we want to make assumptions about the population. But there might be many things going on. Maybe I am asking an employee, and there are experts just doing research on surveys, how to make right questions for surveys, like how many hours do you sleep per day? And then they are not telling the truth. Why? So maybe you need another question at the end to make sure, or to test if the first question was true or not, you know? Well, there are many people working in the field of statistics in psychology that are experts on surveys, very interesting field. Okay, so now we already have presented some of the terms that we are going to be looking into in the future. There are more. Frequency distributions, mean, which you can maybe also hear about average, median, mode, covariance, variance, standard deviation, fit value, percentage, probability distribution, sampling. Okay, let's have a look at all of this today, at least, and a couple of things more. The amount of error between sample statistics and the population parameter is referred to sampling error. This is what we just saw now, okay? This is the error, and it's related to the sampling. It is not always your error, okay? It can be an error, maybe the person who was coding the survey allowed, for example, to provide a string when they any kind of a string when you were asking for location, and then some people wrote the address, some people the postal code, some people the city, some other people the country. Okay, inconsistency. So you might have this problem. So the question is, how do you solve this? So you can aggregate by country level, and then you will have some missing data, maybe, or not. You can aggregate at the regional level, and maybe you have some missing data or not. So you are making decisions here. It can also be related to the fact that you don't have access to all the employees, and you can only be able to talk with 100. It is 100 employees in a company or a population of 120,000 enough? Maybe yes, maybe not, depending. Okay, and what are you asking and what do you want to do? Just for an example, if you have a population of 50 million, how big do you think is the sample? Please write that you need to take. Please write this in a piece of paper. More or less. The answer is not on the slide. You, of course, can Google or ask ChatGPT, but I want you to think, like, to confront. You already did it? Can you read your answer? Comment? Correct. You have a number? A number. Okay, so you have a population of 500,000 individuals. Yes, and you want, for example, to know which political party they are going to be voting. You have 5, 10, 20 different political parties. How many people do you need to ask? How big do you think that your sample, your random sample, should be in order to have a very good prediction of 5,000? Sorry?
No, voting age.
40.
Voting age. Voting. For voting.
Okay. 10% would be 5 million. Sorry, 5 million. Okay. What else? I mean, what did you read? What did you wrote on your piece of paper? Yes. 15. Okay. 7.5 million. Incorporating 30,000, 60,000. Someone else? 500,000. How many? Someone else? Confidence interval of 95% or 90%. I will enter out on a confidence interval for the next week, but more or less this, which means that you have a 90% probability. Yes, that is the number with a standard deviation or two standard deviation from that number. Well, it is more or less 8,000. 8,000. So for 50 million. Yes. More or less. 7,900, 8,100. That's the number.
That's twice different numbers, but now 8,000 for 50 million or 500 million?
It is for 50 million individuals. They need a sample which is around 8,000. I'm telling you this because I was also working in a project related to the influence of disinformation on social network and Twitter and other things on political behavior. And if you look, for example, in the campaigns that the professionals are doing, the demoscopic agencies are doing, they are more or less taking these numbers between 7,900 and 8,100 for a population of 45 million to 50 million. There are rules for that, okay? We are going to be looking into those rules if you are interested in. I just wanted to make you aware, okay, of more or less the magnitude. And we will talk later about why is that law of the large numbers. Well, statistics involves the measurements of variables, right? So we're going to be working with some kind of data, and you already know different forms of data. You know Booleans, you know strings, yeah, strings. In the statistics, we are usually going to be defining data and variables into qualitative, which is nominal data, nominal scale, quantitative variables, which is ordinal scale, discrete variables, interval scale, and continuous variables, which are in ratio scale. So depending on the kind of scale that you have, you can do a specific kind of thing. So for example, if you have a nominal scale, you cannot calculate the standard deviation, right? So you have to be aware on the kind of data that you have so that you can apply the specific kind of models. About the scales, when you have nominal data, we can say, okay, for example, country of origin. You can say, okay, country of origin is this one, is A, country of origin is B, A is not equal to B, or whatever, or A is equal to B, whatever it is. So classification of data, or classification of qualitative characteristics. Real numbers are possible, okay? I can use IDs 001, 002, 003, 004. It's a number, but for me, it's a string, and I need to know information about the metadata behind it to not code it as a continuous variable, right? You have here the delimitation. It is the designation of qualitative characteristics of a specific individual or subject. We cannot rank them. In the moment when we are making a ranking, 1, 2, 3, 4, 5, then we have an ordinal. Okay, now we can rank them. If you can rank the options, even if they are a string, yes, I like it a lot, I don't like it much, maybe I like it a little bit. This is ordinal, right? Do we agree? It's a string, but I can work with that in a different way, because now I can see that A is better than B and better than C. Important for you is always to don't fall into traps when you have big data sets in which you have A is better than B and A is better than C, but C is better than B. Problem. This is the Arrow theorem, the theorem of Arrow. So always make sure that the order, the rank, yes, is complete. And there are no loops inside it. So you have the order values. What is the problem that we have with order values? I'm asking you, do you like this lecture? And you tell me, no, I don't like it at all. And then I ask you the next one, do you like this lecture? And you tell me, a little bit. My problem is that I don't know what is the distance between I don't like it at all and I like it a little bit. Yes? So I cannot set what is the distance. For that, I will be needing intervals. I need to set up intervals. So if I am asking you with a Likert scale from 1 to 7, being 1, you don't like it at all, and being 7, you like it a lot, how much do you like this lecture? And then you provide me with a 1, you provide me with a 2. I know that the difference is between them is 1. And now I can do a star. I can subtract. I can add. Oh, it's in German, Gleichheit von Intervallen. This is, sorry, the intervals are always the same. Okay, Gleichheit von Intervallen here. intervals are always the same. The intervals are always the same between the data. You understand? If you have rational number, then it's perfect. You have a ratio, so you have, very important, you have some kind of 0 point that it is natural and makes sense. It's 0. So if I'm asking you, for example, how cold is outside when you have 0 degrees Celsius? What do you answer me? It is very cold. It is not cold. What does 0 mean? Does it mean that it is not cold and it is not warm? It is just no weather? No. This is why Celsius is an interval. It's not a ratio. 0 doesn't mean doesn't exist anything. Do you follow? So the 0, the meaning of the 0 has to be complete. Yeah, if 0 means nothing. This is a big difference. If you want to always identify what is the difference between interval and rational, think about that 0. Does the 0 provide me information about emptiness or not? If yes, then perfect. I can do a lot of stuff with it. I can actually apply almost all statistical methods. But if that 0, it is not providing me information, it is arbitrary. Why it's 0 in Celsius? Because this is the freezing point of water. Then, but it could be something else, like in Kelvin. Yeah, Kelvin is different. Then it's an interval. Do you follow? So the thing about the scales is that you can plot them in similar ways, but they will always, and they will probably look the same, but they will provide you with different kind of information. We have a nominal variable, ABC, again, as an ordinal variable, an interval, and a ratio. I don't know what's going on. I think that they are making some kind of proofs of the system. Do you understand this? It's easy, isn't it? And can you connect this with the course that you have about Java and strings and so on, and 8 bits, 16 bits, 32 bits, and so on? Yes, probably yes. Well, I hope so, because I'm not going to be entering into that. Indicate the scale level for the following example. So, sex. What is it? Nominal. Okay. It is not Boolean. Okay. It is not 1 or 0. It can be 1, 0, not defined, prefer not to enclose. Okay. Social class. It is nominal, ordinal, interval, or ratio. Can be both. Can be both. Can be both. Yeah. Okay. Can be nominal or ordinal.
Yeah.
And the intervals are equal or not?
Yeah.
Here in Germany, if you make more than 300,000 euros per year, you are on the high income, very high income. Okay. Exactly, and then you will pay taxes depending on that. Okay, but the interval maybe is not always the same. Some people you will ask, and they will tell you that the best thing is to be on the what it is called the high income. Other people will tell you that they prefer to be on the low income. Right? Income tax. Depends on what? Interval. Depending on how much money do you get, you are in one or the other. Exactly. Exactly. Perfect. But probably with the income tax, we have numbers, okay, or percentages. Yeah, percentage. With the social class, probably we don't have it because it's a social science or humanities term. Yeah, but maybe you are. Okay, this is very interesting. Yeah, of course. But it depends on the perspective that you are taking. Okay, so a couple of weeks ago in Germany, they asked the people which social class do you belong to? Okay, and most of the people they answer, I belong to the middle class. Most of them, even the lower class and the higher class, they say I belong to the middle class. Everyone was middle class. But then they made some statistics and they say no, you're not part of the middle class. You are part of the lower class or the upper class. How do they do that? On money, on income. So they're looking into the income. So this, even if we can define them in different ways, if we are very strict, we will say income tax will be an interval, social class mostly is ordinal, but it depends on how do you define it or in which context. Temperature in degrees Celsius. It can be, you can work with it as usually it's going to be an interval. Yeah, it is an interval, okay? Scale, but most of the people work with it as a ratio. But there is a nice paper written by a statistician that when you go very deep into models and so on, getting this kind of variables and using this kind of variables as a ratio can generate problems, okay? But well, it is an interval. Wind speed. Okay. What is the difference between the wind speed and the temperature? If you have 0 and you cannot have negative, at least that you are measuring direction, vector, right? Yeah, I'm very sorry. I know that this thing with the Celsius is very tricky, but this is why I'm telling you. You see the difference between temperature in degrees Celsius, 0, it doesn't mean that there is no temperature. If you have wind speed 0, 0 means that there is no wind, right? The wind, yeah. But I want you to answer. So body weight. Thank you. Social grades, school grades, sorry. It depends, exactly. It can be a ratio, or it can be an interval, or it can be an ordinal, depending on which part of the school, on which school system you are. Here, I was thinking more on A, B, C, D, and so on. What would you say if it is A, B, C, D? Ordinal, right. Exam points. No, because if you have 0 points, then you have 0 points. Yeah. Time. I love time. Time. 0, 0. I'm going to sleep. It is very early or very late? My mom always told me it is 4 in the morning. Say, it's very early. Yeah, you follow? So if it is hours, the interesting thing about time is that it is how you call it? It is recurrent, like cycle. Thank you. So it's a cycle. The weekdays, same. The months, same. Okay, except of the years. Except of the years. Time is not date. So what is the answer? Interval, right. Eye color. Exactly, same as sex. Duration of treatment at the doctor. Okay, who has said interval? Explain it to me.
There is a period of time.
And if you don't go, 0. You die. Okay. Hope that doesn't happen to anyone. What I mean is that if you can 0, you can interpret 0 as the lack, the emptiness, the no, you know, and this is why it is rational. Preferences. I would rather not. I prefer to. Preferences. What do you think? What? How are those nominal preferences expressed? And that means that A is better than B. Then ordinal. Yeah. Because we cannot set what is the difference between, or what is the distance between one and the other. Yes? Okay. So we have it. Now I want you to do the following exercise. I want you to consider the methods of empirical measurement for the following variables of empirical observation. Do you understand empirical? Empirie? Empirical. Can someone explain it, the root of the term, to those that didn't study Latin or they come from a different mother tongue, that it is not Roman? Empirical, something that is empirical. That it is based on experience. And experience leads us to experiment, okay? So we are doing an experiment. For example, we want to measure the internet speed. How do you do that? How do you do that? You go to Vodafone speed thing, isn't it? Yeah, exactly. But you need a variable. Which variable do you use? Mega, okay, or kilo, or whatever, depending on the communication protocol that you are using, right? And the scale is Y. Okay. And this is when the guy is asking you, or the person on the other side of the phone is telling you, did you turn off the modem? Please turn off the modem now. Yes? So cognitive stress. How do you measure cognitive stress? No. Methods, sorry, and it is in German. Methoden means methods, okay? Which methods? How do you implement this in experiments? So you have to find out cognitive stress in students, and you are working with a psychologist and a social worker, okay? And you are the expert in computer science. And now they're asking you like, okay, I have access to all these students. Tell me, what do you need to know about them? What do we do to get the sample? Questionnaire. You ask questions. Okay, survey. What else? Come on, we are living in the world of digitalization. Can you do something better? Experiment? Okay, I will see. Yeah, if all the students they have an intelligent watch, maybe I can get heart rate, blood pressure, stuff like this. Something else? Maybe some questions. Yes, sir. Okay. Participation, interaction, observation. There are many ways, okay? But now the question will be, which, if you are doing surveys, what kind of scale do you have? It will depend, isn't it, on the question? Then maybe the first question might be, which faculty are you from? And then if they say faculty of whatever, nominal. If you're asking them, how do you feel today from 1 to 7? What do you have? Ordinal. If you are asking them, okay, do you feel very good or not that good and so on? Interval. And if you ask them, tell me how many hours did you sleep last night? Ratio. Okay. So it depends, okay, the survey, and this is us looking into the data and deciding which kind of data do we want to have. And do you understand now that sometimes by selecting one specific scale or another, you are losing data? You are losing detail? Yeah. So the more we aggregate our data, the less detail of the reality we are going to get. About the brain activity and so on, who was saying this? You both. Or who? This and yeah, and that will be okay. But what is the metric? The scale. Okay, and the zero means. And okay, perfect. And which kind of scale do we have? Yeah, and we have 4 different scales. Perfect. Now, next thing will be precipitation, rain. How do you measure this? Per square meter. Also, you take a cubic meter. Okay, so you take a 3-dimensional object, and you take one specific scale, which is going to be the meter, 1 cubic meter. You are measuring volume and maybe a specific time frame, right? This is how it is done. And what kind of a scale do you have here? Perfect. Now, volume. You are listening to music. What? Okay, and how do you measure it? dBs. Decibel. Yeah. Perfect. And now sportiness. How fit you might be or someone might be. The level of sportiness. Fitness. Ratio of fat and muscle. That will be which kind of scale? Perfect. Yeah. Can you have 0? No, but it exists, the possibility. So in your logic, it exists. The only thing is that you will not have it in your sample. Yes, because your sample starts at some point. But this is why you in the model you will have the axis, the ordinal one, yes, the y, and then in that the axis and the ordinal axis, and then there will be a point of intersection. And that point of intersections in newborn babies will be 3,200 grams of weight, for example. So you don't expect to have 0, but 0 is an idea. Is an idea that we can conceive, right? Because you have a ratio, and the ratio accepts that 0. Do you follow? I think that's an interesting example. What else? Likert test. You put all the people running 10 kilometers and And what do you want to measure? Time. Okay, then time in, okay. Yeah, specific. Yeah, it's okay. It's okay. And what kind of scale do you have? Why intervals? I mean, of course you can have intervals because you can reduce the quality of the data that you have. You have time, and then you don't look at the time. You classify. Sorry, let me finish this idea. You classify all the individuals into different classes, and those classes, they have a specific, not a specific distance, but different level of, they have a rank. Yeah, but you can also say, okay, you just use the watch, isn't it? The time, and then you just provide that time, and that will be a ordinal scale. And afterwards, how do you transform that data from, you go from ordinal to other scale? That is up to you. You can go for ordinal, you can go for interval, or you can stay with the ratio. Other things, hack trick. Okay, and how do you measure this? Okay, in a specific moment in the day or a specific time per minute will be. And is that a ratio? Is that an interval? Is that a ratio? Okay, perfect. Yeah. One last one. Someone with a funny idea? Or interesting one? BMI. Okay. This is also a ratio, actually, between height and weight, something like this, I think. It is used, or it was used by doctors. I think that not anymore, or at least it is not recommended. But yeah, that would be another. Yeah, I mean, yeah, also possible. And which kind of data will you have? Interval. How does the data look like? It's a composite indicator. This is composed of individual indicators. And can you have a zero? Then it's a ratio. Yeah. Okay. So just here some examples for you to remember. I can imagine that for spottiness, fitness, you can use different kind of scales. Yeah. Okay. Now let's move into, now that we have seen different data types, on the next week we are going to be looking into how do they are expressed into a programming language. The idea, just for me, that I need you to understand is that when you are moving from rational to nominal, you are losing information. Okay, it's like if you are aggregating somehow. So you have a loss of information that you have to always take into account. And the other way around, if you are going from nominal to ratio, you might be generating data and making hypotheses about the data that maybe they are not true. And this is also important. Yes? Okay, now, the thing is that, let's say that we have data. We have some kind of data. The first thing that we are going to be looking into is how is the data distributed? What is the distribution of the data? How does it look like? That's the first thing that will be interesting for us. So what do? We look, in this case, we have X, which are the results that we can have, okay? The different, which kind of variable do we have here? Which kind of variable, not of a scale? Discrete? It's a variable, it's a discrete variable. It cannot take comma, okay? Periods. It goes 10, 9, 8, 7, 6. So we have the discrete variable, and then we have the tally, which is the number of times that we have it in our sample. If we assume the frequency is the number of tallies, the number of times that we see it. We have just, it's like times that we have seen it, we have the frequency. N is 26, and we can also calculate the relative frequency, right? Is an error there somewhere? Or I make a mistake? No? Sure? Something interesting? No. Okay. Well, this is the kind of distribution tables that you are going to see all the time. And most of the graphics that we are going to be generating, they are based on that. Actually, based on these graphs, we generate and we understand the distribution of the data. You probably know the normal distribution of the data, normal. But maybe you also know the binomial and the t-student, or many others. So how does it work? It's very easy. We have different values. And the only thing that we are doing for the moment is just counting. 1x means that it is present in my sample. Zero doesn't mean that it doesn't exist, the data. It's not an NA, okay? Zero means just that we don't have in our sample that specific number, but exists in the population. This exists in that scale that we are working with. So, what we can do, now that we have seen this data, is to more or less understand what is the average. So what is the expected value of the data based on the dispersion of the data on the, the mean is the expected value. And we have an overall idea on the kind of individuals that we have on our sample. We can calculate the mean, the median, the mode, and we can calculate the covariance with itself. Okay? Everyone. Variance we cannot calculate, but for that, well, actually, variance we can calculate, the standard deviation also, set value we can calculate. The only thing that we cannot calculate is the covariance with another variable because we don't have it. We can still calculate the cumulative frequency, which is going to be starting from the top. Okay, 26 is the number of individuals that we have, and then as we are following the relative frequency, which is like the percentage of individuals that are on that specific class will be 10, right? The cumulate, they have all of them they have 10 or less. On the second row, what we see is that all of them, they have, maybe if it is the mark, it will have a mark of 9 or less, and so on. And then we have the PR, which is the percentile rank. Why is this interesting for you? Look, let's say that I do like this. I have some kind of density function, okay, that describes the data. I know that this is 100% of the data, right? So I can start looking into questions to, is the 90% of the data here? Okay. I can start looking into, okay, what is the 10%? Maybe it is here. Just taking random numbers. I'm not making any calculation. And then you can start looking into what is the actually an odd layer, something that is an unexpected value. What is something that might be actually representing a phenomenon that I would like to look into. These frequency tables are very easy to implement, and most of the algorithms that we are going to be looking into today, they are based on these frequency tables, or tables that are very similar to that. So I want you to calculate, do you understand, do you know how to calculate the frequency? Yes, do you know how to calculate the relative frequency? The cumulative frequency? And the percentile rank? Then can you please calculate all of this for the following sample? Transforming the data, you will record the rest of them. So for the moment, it's trivial, but I want you to do it. So let me know when you're finished. F is the frequency, okay? The number of times. It's a number. The frequency is a number. The relative frequency is a number. Yeah? And the cumulative relative frequency is equal to 1. Like in identity proof. The cumulative frequency starts on the top. The cumulative number of individuals. We're not looking into the number, into the review. But we are looking into the individual participants. Yeah, he asked if he and to start with 100%, you have all of them inside your sample, and then you start going down. It's the data is solid, so you can put the data source already. You know, like, on the top, about that. So, you understand? So what is, yes, question? What, should I explain what? The relative frequency. Look, the relative frequency is the number of the relative number frequency based on the total number of individuals, or on the total number of samples of anyone. In this case, would be 4 divided by 26. 50. Yeah. Everything fine? You're looking a little bit like, okay, conclusion. Now, what is the frequency of 32? Everyone agrees? Because I don't have the solutions here, I'm sorry. So, the relative frequency of 33? Zero, 1, 5 or 5? Okay, so it's the relative frequency, yeah, right? And then the frequency is 5. I think that was the, okay. The cumulative frequency of 34. 20 or 21? 20 exact, 20? No period? 20. Okay. And the percentile rank of 29? 5%, which means that there is only one individual, or? Yeah, isn't it? Okay. Good. Yes, question? The cumulative frequency and the PR. Okay, the cumulative frequency, in this case, what we do, first what we do, let's say you have the data from the highest value to the lowest value. This is first transformation of the web. For you, okay? Now, another way of market, you have to make sure that all the individuals, okay, you get all the values for the individual also on the side. You don't have only one variable here. Yeah? Well, don't have order from the data. Based on X. And we want to calculate the cumulative. If you start from higher value to lower value, I can say that all the values are. All the individuals are the value of the maximum of this 34 or less. Right? So the cumulative frequency is 1, 2, 3, 4 by 5, 20. That's the cumulative frequency. Right? 20. For the next numbers, we have to subtract all the individuals with 34. That will be 33. What is the cumulative frequency of 33? Look at the table. There are 18 values with the value of 33 or lower. Right? And so on. For the percentage graph, pretty similar to the percentage. What is the percentage of individuals in a sample that has a score of 33 or less? Or sorry, 34 or less? 100. 33 or less? Thank you. Okay. Yes, the same as frequency, but it has been only maybe 3 or 2 less counted. Okay. You have to calculate only is the amount that we are doing in order to define this one. So it's just information of 1 kilo. Yes, no, yes, yeah. Some other questions? Now, what do we do if we have this kind of data? Class intervals. This is what you were waiting. Now we have class interval. What is a class interval? Class interval refers to groups of scores. You know, by K, which is we're going to be denoted by K, which is better. Okay, the German class starts with K. We could have taken another class, but K, we can also think on it as a constant. Okay, this is why we use K. The interval times will be symbolized by E, refers to the number of scores in the class interval. In this case, we have 3, right? So for 45 to 47, we have 45, 46, 47. And the next class interval, it's going to be 48 to 50, which has an interval size of 3. So the interval in this sample, or in this state that we have generated in this class, is equal for all of the different classes. Can it be different? Yes. We will look into that later, okay? How to make them a little bit more fancy. And the range it refers to the amount of spread in a distribution of best form, which means it is the difference between 83 and 45. Right? Everyone's following? So what do we have here? We have a frequency. We have a frequency, one individual between 81 and 83. Maybe this is the weight, okay? Another individual between 78 and 79, and so on. You don't care about the class here, as you can see. You don't care about the class for calculating the relative frequency, right? Do you follow? In this case, it is, we say in German, it is Wurst. It is sausages. I'm sorry for those German hearing this. But what I mean is that it doesn't have an impact. Okay? But we are having an impact if we have the data in a different scale and we are creating classes. So actually, you can do this exercise if you want. I don't think that we need to do it, but you can calculate the relative frequency, the cumulative frequency, and the percentile run. you will see that both for classes, for class intervals, and for ratio, scale, or continuous variables, or discrete variables, ordinal scales, there is no kind of difference. I will upload the slides afterwards. Now I have added a central frequency column to the slides. Okay, I always like to ask these questions on the exam about this table, and yeah, I think that it is very necessary for you to understand these things that you can in the future not make silly mistakes. So the good thing is that we can calculate some kind of central tendency with everything. So for example, if we have the nominal scale, I can calculate frequencies, right? Because if we are looking into this, 10 might be also a nominal, an ID for an article. Do we agree? So I can calculate the frequency, and I can look into the distribution. Okay, what is the distribution? Well, it is associated to the percentile rank. Do you see here this percentile rank again? How it is here represented somehow? Do you follow? I just want you to understand the heuristics, okay? The idea behind everything that all the times in statistics. I don't want you to memorize stuff. I just want you to follow and to understand the different building blocks. Now, if we have an ordinal scale, I can calculate a median. I can calculate quartiles and percentiles. If we have an interval, again, we can calculate the same as before, but also the arithmetic mean. And if we have rational, we can calculate the geometric mean, arithmetic mean, harmonic mean, and a weighted mean, whatever we want to have. Do you see how the better the information that you have, the more things you can do with the data? Okay, so at some point, you will have data, and you will have to decide which machine learning method to apply. You are not going to be able to apply the machine learning method that you like the most all the time. Why? Because it depends on the data. The data is the barrier that you have. You have to first understand the data, look into the data, and then think, which machine learning method, which kind of a statistical method allow me to work with this data? So you have a toolbox. You open your toolbox, you look at the problem, and maybe you try first with one thing and then with the other, and sometimes you need two tools at the same time. And this is the funny thing of being a computer scientist, okay? Is this clear to everyone? Okay, then we make 5 minutes or 10 minutes, 15 minutes as you want. 15 minutes, okay? 15 minutes. It is just, I will want to get home earlier. This is 15 minutes is okay. And afterwards, I'm gonna try to explain you how to make these interval classes, okay? How to make the intervals. They are gonna be using some kind of defaults. Okay, so these softwares, they are not generating an image just like this, but they are using some kind of data. What is a histogram? A histogram, it's a plot of the frequencies with bars. That would be a histogram. Okay? And as you can imagine, if you have rational data, maybe you have all these points. What you are doing is grouping data into a specific intervals. In this case, what we are doing is if we have a 3.1, 3.2, 3.3, we are transforming the rational scale into a discrete scale by giving a 3 for all of them. Yes? You follow? Or you can just use just for the visualization, generate those scales, even if you are not modifying your data frame. So there are some kind of rules of thumb, like for example, you would like to have more than 5 classes and not more than 25. Can you imagine why? Because less than 5, it doesn't really make sense to classify the data in such big groups, and more than 25, that would be too much. Do you have the 5 logarithm of n being n the number of individuals or the number of variables that you have? The square of n might be another rule of thumb, and 1 plus 3.32 logarithm of n will be another rule of thumb. If you look into, and this is the first time that I'm presenting you a real function from a real software, is the function for plotting a histogram. So it works like this, and then you open parentheses, you provide the vector or the matrix or whatever data structure do you have, and you want to plot it as a histogram. It is providing us with some information. If we look into the manual, the information that we have is that for breaks, we have start, which is calculated based on n plus start, which is another formula that you can also use independently. Other names, which algorithms are supplied, are spot, which is another formula that you can be using for the breaks, and FP, Friedman diagonals, which is corresponding with corresponding function n plus Scott and n plus FP, which can be with FP5. So what is this of the break? Breaks are based on the idea that data has some kind of natural breaks. And how can you identify them? By using, for example, one of these formulas. That's the idea. It's like if you're looking at this, and you can see a break here, isn't it? There is a natural break on the data. That would be like this one, isn't it? It looks like there is a kind of natural break here. And it might be another natural break here. Yes, on the tails of the distribution, tail of the distribution. Well, this is the idea. When you are plotting stuff, it will be depending on the kind of variables that you have. It will be looking differently. If you have nominal variables, for example, for the types of psychological therapy that a patient might have, you can have behavioral, cognitive, existential, Gestalt therapy, humanistic therapy, interpersonal, psychoanalytic. They are not better or worse. They are different. But what we have is the frequency on the y-axis, which is the number of of patients that we have in our sample, right? That are going to one of those specific therapies. On the other hand, what we have is a histogram of temperature, which is a rational scale, which is a rational variable in a ratio scale that we can plot in a continuous x-axis that goes from 60 to 100, and maybe it's Kelvin or Celsius. We still don't know. And what we have again is the frequency. Maybe we have data for different hours, for different days, for different weeks, for different years, for different countries, for different cities. We still don't know. The temperature plot contains bars. Why do we have those bars and not other bars when we are plotting this? Is because of the algorithm that is the default or that we have chosen while writing the formula. Do you understand this? So actually what will happen a lot to you in the future is that maybe you are running an algorithm or a function in Python, and a colleague of you is running the same function in R, and the results are different because they have different defaults. And even because the algorithms, they are implemented in different ways. So it is not just about efficiency, but actually about the statistics, the concepts that are behind them. Do you understand now? Well, if we are looking into this example where we have a vector X with an n number of individuals or measurements, data points, which is 8.7, 6.3, 21.5, 8.7, 9.2, 5.8, 4, 7.6, 7.4, 6.9. We have a ratio state. We can calculate all the different rule of thumbs, okay? And we can see that all of them, they are different. The first one will be something between 5 and 25, so you can say 5. The second one will give us a 5 logarithm of n, 5. The square of n, 3.16. The 1 plus 3.32 log of n, 4.32. So there is a tendency of all of those rule of thumb to, they are more or less on 4, yes, 4 or 5. Do we agree on this? So we don't use one thing, we use 4. Okay, we don't use one rule of thumb. We know, because we are experts, that there are many. So we can calculate all of them and decide the interval size is going to be 4, for example. The interval size, the formula will be I, which is the interval size, equal to what? The range, yes? We can calculate divided by what? By the number of intervals that we want to have. Okay, in this case, it's going to be 4. So we have 17.5, which is the radio, the range, divided by 4, which is equal to 4.375. Do we agree on this? Yes. Now let's apply then the class to the set of data. We have different buildings. The buildings have an ID number. The ID number is 01, 02, 03, and so on. And we have a size, which is the variable that we are working with. The size might be the height, or it might be cubic meters, or whatever. On the right side, what we can see, we can see the 3 different colors for 3 different classes. What is the problem? That we have a class that is empty. Right? That is empty. So sometimes using rule of thumb is not enough. So what else can we do? We can use equal manual intervals. We decide what will be the intervals by hand, let's say. So we sort the data and we think, okay, it makes sense to do this, it makes sense to do the other thing. It makes sense based on what? Based on domain knowledge, based on talking with experts on that field of psychology or building or whatever, and ask them, what would you do? You are the expert. I am the only one. I'm just coding. Equal interval is another option. You say, okay, let's do 5 meters or whatever. Just take that. I don't care. Then you divide the whole data set, the range, in intervals of 5. You can say, let's define an interval, and we'll have different intervals, different size of intervals. I don't care. Another possibility is to use the quantiles. So the 25% of the data, the 55% of the data, 75% of the data, and 100% of the data, which is similar to what we have seen before, the percentile rank. But in this case, we are going to be focusing on the 25%, on the quantiles. We can also go for the deciles, and then we have 10%, 20%, 30%, and so on. Then we have 10 classes, interval classes. We can go for the centile, and then we will have 100 of them. The good thing about that is that we will have always the same number of individuals on the different classes. So we will have no empty ones. Do you follow? You can also use the natural breaks, which is what we have in the default for breaks using the hist function in R. We are going to be looking into it because that will be our introduction to standard deviations and our introduction to arrays and our introduction to clustering. And then the standard deviation. You can also say a group will be based on how many standard deviations do we have from the mean, which could be something like this. Let's say that the mean is here. I can calculate means plus a standard deviation. And I will say that this is one class interval, and this is going to be another one. I can also do 0.5. Or whatever it might be interesting for me. Questions? Okay, so quantile. How do we do that? So you use the median to divide the ordered data set into two halves. Yes? And then you do that again with each one of them. Then you have the 25, so you have the first quartile. Then you have the median, which is going to be your second quartile. And then you have the third, you have your third quartile, the 75%, which is the third quartile. If we have 25, we have here the distribution, we can say 25% of the data. Points might be here. Another is the mean or the median, sorry. The median is different to the mean, you understand this? Okay? No problem. Then you have Q1 here, which is going to be this thing. You have median, which is equal to Q2. You might have Q3 here. And then you have a final value here. As I said, what is interesting is that you always have the same number of elements inside each one of them. Because it is based on what? On the FQ that we have seen before, the frequency ranking. The one. Percentage rank, PR. But we have calculated before on the tables. There are other methods, okay, to calculate this, but well, it is always the same. If you have 5 quantiles, sorry, you are going to be looking into 20%, 40%, 60%, 80%, 100%. Do you understand? And so on. You can decide how do you want to do this. To calculate the median, the middle of the ordered list. If you have odd numbers, it is very easy because you will identify always one number that is going to be in the middle because it is odd, right? So if I have 3 numbers, 1, 2, for a vector of order, it's going to be this one. But if we have 1, 2, 3, 4, I will have to identify which is the point in the middle and take that 1 and 1 plus and divide by 2, 2.5. Yes? These are the formula. Everything fine? Well, now the interesting thing, the natural breaks by Jenks. Let's look into the natural breaks by Jenks. The logic is based on the classification of values based on natural breaks, based on the concept of intra-class homogeneity, how homogeneous are class objects between objects that are inside that class, and external heterogeneity, how different are objects belonging to 2 different classes. Do you follow? How do we do this? We calculate the sum of a square deviation for a right mean. I'm going to put this here. We're going to see this a lot in the future. And it's the sum of a square. We call it like this, okay? The sum of a square error, the sum of a square. Usually it is just reduced to the sum as a square. And you can see the formula. Is the sum, we are adding each deviation of each one of the values that we have, the individuals, to the mean, which is some kind as the error. The error, why we can see this as the error? Because we have an expected value, and the mean is the expected value. So if I am asking you, how old are you? And then someone of you tell me, I'm 45 years old, I'm going to say, okay, I didn't expect that. I expected you to be 19, 20 years old. So I have a deviation from my expected value, which will be maybe the mean based in a survey that I am doing over all of you. So what I have is the sum of all these errors. And why do I do a square? Because I want to give more value to those individuals that are very far away from the mean. So, do you understand? If I have a mean, I have some values here. And I have one value here and one value here. I am squaring, doing the square. I'm going to be giving more value to these two persons here by calculating the mean. By calculating the sum of the squares. So we calculate the sum of the squares, and then we generate all possible class combinations. Let's say that we have 4 different numbers. What do we mean by all class combinations? Well, it can be that we generate one class, which is going to be class 1, class 2, going to be only one element. And in class 2, we're going to have 3 elements, the rest of them. That will be the first possibility. I have 2 classes, right? There is another possibility. I have, we call this A. And B might be A1, it's going to be 1, 2. A2, it's going to be 3 and 4. Another possibility, right? Well, so what we do is to generate all possible class combinations. On step number 3, we calculate the sum of a square deviation for that specific class. And as you can see, there is a difference between the array and the class. So what I'm doing is calculating first, what is the sum of the square of the whole array? And then I'm going to be calculating the sum of the squares of that specific class. What is the sum of the squares of 1? 0. I have 1 minus 1, 0. Nothing. What is the sum of the square of this one? It's going to be 2 minus 3 squared, 3 minus 3 squared, 4 minus 3 squared, and the sum of all these. Yes? What is the homogeneity of this class? Perfect, it's 0. So the error is 0. What is the homogeneity or heterogeneity of this class? It is higher. Do you understand? And what is the final thing that I'm going to do? I'm going to calculate the goodness of fit, of variance fit. The variance measured by that variance that we have. Okay, the error, that error that I'm calculating. It is not the standard deviation. It is just the sum of squares. Which is the formula that you have here. So goodness of fit, it is going to be the sum of deviation from the array minus the sum of deviation of the class combinations divided by the sum of deviation of the array. Do you understand the algorithm? Okay, no, but let's calculate this. You have a vector 4, 5, 9, and 10. Let's calculate the sum of square deviation from array. What will be the first one? SDI. For group number 1. You not understanding anything? Or it's just too trivial for you that too easy? Or no, yes, no, but wait. So yeah. It's the mean, not the mean, not the median. The mean. But I have a question for you. I really need feedback right now. One more. Can you stop, or I said too late? I can be much slower, but I expect feedback all the time. And before we were talking about voting variables and so on, I was getting a lot of feedback and I was thinking, okay, today is a nice day, and now I'm asking you, like, nothing. So should I repeat the concepts again? Because I can do that. If you didn't get it, I can repeat the concept, but I need you to understand this thing. Should I repeat the concept? Okay. SDIN, the sum of deviation, okay? The sum of square deviations. So what is the sum of square deviation? I'm just telling you the sum of squares of the deviation is the deviation of the whole array. What is the array? 4, 5, 9, 10. Yeah, that's the whole thing, the whole data that I have. It's just 4 because I just take 4 elements for the example of the course, because you can imagine that if we do this with a large database, we not finish it. But just for 4. So we have 4 elements. And what is the standard, the square deviation? It will be, the first thing that we need to know is what is the mean. What is the mean of 4, 5, 9, and 10? I don't know. Can you calculate it? Do you know how to calculate the mean? It's the sum of all the elements divided by the number of them. It's 7. Okay, now, first thing that we need is the mean. Because the mean is the expected value, is what I expect to have. Yes? Now, it's the value. Now, what is the deviation of the first element of the array, which is 4, from the mean, which is 7. Okay, and this, I want the square. Okay, nice. And for the second one, that is the sum of square deviation for the array, from the array mean. Do you understand? The next one will be 5 minus 7. 7, isn't it? Square, which is equal to. Okay, now for the third one. Wait, you're now an algorithm. You are reduced to an algorithm right now. Have no personality, no nothing. Just a computer machine. You are writing for me. For 9. Do you see also why do we square? Why? Exactly, because we want to positive. I mean, we can also take the option. Yeah, but by squaring, now we are giving more weight to those that are far away from the mean, and I make sure that everything is positive. As you complete, did you complete the table? Is this what you have? Okay, perfect. Standard. So SD sum of square deviation array mean square. Deviation from the array, the whole data set, mean. It is the name of the thing. I mean, it's not rocket science. Do you understand now this?
Yes.
Okay, great. So now, for the first possible combination, what will be the first possible combination? 4, 5, 9, and 10. 4 is one group, and 5, 9, and 10 is another group. That would be like the most easy thing, isn't it? Now, we need to calculate the sum of square deviation from the class mean. What is the class? The class is 1, from 1 to 1. And this is class number 1, and class number 2 will be from 5 to 10. Do you understand? So now we need to calculate CN for group 1 or option 1. We still have 4, so it's 4 means 4 because it's the mean. We still have the same formula. Now we have, I can call it x8 and xb. This is going to be 4, and for b is going to be the sum of x this divided by nb, which is equal to 5 plus 9 plus 10 divided by 3, which is equal to okay, 8. So what do we do now? We take the number, the first element on the group, minus 8. We square it for this group. Yeah, you understand? This is one group now, and this is another group. Yes? It's good? Nice. Now we're talking. Now, do this. I can do it at the same time. 9 minus 8 squared. 10 minus 7 squared. And we have it's like this. Oh, sorry. I know, no, wait. Perfect. Sorry, I make mistakes all the time. It is normal. So, you understand how it works now? Do you understand now the logic? So, what is important for me is that you understand what is the difference between the array and the group, that you understand why do we do the squares, and the different combination possibilities. What is the next combination possibility if, and this is also important, k is equal to 2? Because we want to make only 2 groups, okay? I mean, we could iterate and then start with 2 groups, and then 3 groups, and then 4 groups, right? But I'm just here interested in equal to 3. So what is the next possible group? Okay, and can you continue the table? Calculate it. And I can provide you with the results here. When you have two groups, you have to calculate the mean for the first group, which is 4 and 5, so 4.5. And then for the next one, which is going to be 9 and 10, it's going to be 9.5. And we have to calculate for the first group or for the first class. Let's say what is the spread? Yeah. I'm telling you number spread. Yeah. Yeah. No point
This one.
is the SDSCM for which what are you talking about? The sum of everything is 0.25, right? And if we continue, we will have the same for the third group. The second group is 0.25, 0.25, yeah, right. And for the final group, we will have 4, 5, and 9 inside 1 or group 1, and then we'll have only one group for 10. My question is, why are we not taking into account other combinations, like, for example, 4 and 10 is one class, and 5 and 9 is different class? Huh? No. No.
Doesn't go in order?
Thank you.
What's the order?
We are here. I cannot make a diagram where I say this bar goes with this bar, and then somehow, exactly, it's a distribution of values that they follow a specific order because we are looking now into rational data, and I cannot say, okay, I mean, it will be possible from a conceptual point of view, say that we have 3 different groups, and group 1 and group 3 is the same. But here in this distribution, okay, we're trying to build an histogram based on natural breaks. We cannot do that. Do you understand? Okay, now, as you can see, what I'm doing is I'm calculating now the SDIM, which is the sum of all of them. The sum of all the errors for the array is going to be 26. The sum of the option number 1, the group number 1, it's going to be 14. The sum of the SDCM is going to be 1, and the sum of SDCM for group 2 or possibility 3 is going to be 14. Do you understand? Question? Thank you. Because what I want to do is to find out which groups allow me, or which configuration of the 3 different ones that we have tried allowed me to maximize the homogeneity among groups And do you understand? And maximize the heterogeneity between them, between classes. Look at this. Let's continue with this example. We have STM equal to 26, right? Which means that in my array, if I take all of them, my population, my sample, has a kind of error. No group, but if I don't group the data, if I don't create group, I don't classify the data, I know that I'm having a square error of 26 units. Do you understand this? Not grouped data. Now, let's try to group the data in order to reduce the error on the different groups. So that I can say, okay, there are two groups that make sense because inside each one of the two groups, the errors are low. Do you understand this? Now we have three different possibilities. The STM of option 1, STC of option A, let's call it, option B, and the SDCM of option C. And it is going to be 14, 1, and 14. What this is telling me is that if I divided the groups following this split, the error is going to be reduced inside that group, which means that the individuals inside that specific group, they are very similar into them, so that when I assume all the mistakes that I'm doing in group 1 with the mean of group 1, and the mistakes that I'm doing in group 2 with the mean of group 2, it is very low compared to this one. Because in this one, yes, I have complete homogeneity on group number 1 because I only have one member, 4. 4 minus 4, 0. Homogeneity, perfect. But in the other one, in the other group, the error is very high. Do you understand the concept? So this is why I'm trying to find out which one of the combinatory possibilities allows me to reduce the sum of squares of errors in each one of the arrays. Sorry, in each one of the classes, the different groups that I'm making. Taking into account that K is equal to 2. And now the only thing that I need to do is to calculate the goodness of fitness. How good do I fit? So I take SDM, which is 26, and for each one of the combinations, I calculate that number. Do you understand? I got this. 0.96. And that's the one that I want. Do you follow? So this is the core idea of all clustering methods. Of everything that you are going to be hearing about unsupervised learning. Do you understand why this is unsupervised learning? Because you don't know what is the right group of each one of them. You don't know what will be the best option. So what you have to define is a goodness of fit metric that you want to minimize. You want to minimize the error based on what? In this case, of the sum of squares, but it can be any other metric that you might want to use. And then you start to try different groups in order to find out how, by dividing the data into different groups and without knowing what is the real label of the data, what would be the group configuration that allows you to minimize that goodness of fit indicator that you have developed or you are applying here. Questions?
So, yeah, understood. These numbers, we should
No, no probability. Yeah, and it is. Let's do the following. Let's visualize this thing, okay? Let's visualize it. Let's try to visualize it. Super. Okay, no, let's do this. We have a variable, x, right? Is a vector equal to x1, x2, until xn. Yeah? My question is, how can I find out if there are some kind of natural groups inside this variable, inside this vector? Somehow, a pattern inside the vector that allows me to classify the individuals inside based on that variable in a way that when I look at a specific group, I think, wow, this is very homogeneous. I see a group that here it has a very high degree of homogeneity. And when I look at another group, I say, this is a very homogeneous group. But when I look to them, I say, but they are completely different from each other. That would be the highest goodness of fit that I can get. Yes, do you understand this? So how do we do that? As we don't know what will be the perfect way to do that because we don't have a label, which the prediction, so we don't have the ground truth, like in supervised learning. I don't know the groups. I don't know what will be the best thing. I don't have data set that is telling me, actually he is from group 1 or actually he is from group 2. I have no idea. I have to start from 0. What I do is I define one metric, which is going to be the goodness of fit. The goodness, how good do they fit? How good can I measure if they are similar or not? The similarity. And what is going to be this similarity measure that I'm going to be using? The sum of squares. Yes? Until here you understand everything, right? So if I look to this data set, to this vector, containing x1 to x2 to xn, and they are here represented by x1, x2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I know that I will have a expected value here. Right. I calculate the sum of the squares of all of them to know how far they are from my value. And I square it because I want positive values and because I want to give more weight to those that are very far away. Do you understand this concept? Perfect. Now what I have to do is to say, just by looking at this thing, yes, and if I can make 3 different groups, I will do something like this. Just based on, like it looks like this one is very far away, this group looks like very homogeneous because they are close to the mean, and it looks like they are very far away. So sometimes every year I have some very bad students, then I have like, some students that are like, and I have 1 or 2 really good students. And this will be my class. But then someone might be telling me, one student might tell me that you cannot classify this good student, bad student, and normal student. I mean, the class of normal student, it is also very heterogeneous. Yes, and I will be asking you, how would you do this? And then you tell me, I can use the natural breaks algorithm. I'm gonna do the following. I'm gonna take the number of hours or the number of questions that the student is asking, which is this variable here. I'm gonna classify all the students based on that. And what I'm gonna do is try to find out a group of students, groups of students that make the similar number of questions. Do you follow? This is what we are going to do. So we are going to be looking into what is the normal error that we have in the data, which is the SDAM, and we are going to be comparing it with the error when we have one group and all of the students are the same, and we are going to be comparing it with my classification metric, which is just 3 different groups, and your classification. And the one that better fits the data wins. That's the idea. Sum of a square. But you can use whatever you want. Okay? You want to minimize or maximize something. And in statistics, we usually take the sum of the squares. Okay? Because it is very helpful. And we will see this afterwards. Yes, and every algorithm that you will see in the future, they are doing this thing, but with other metrics, you know, with other kind of ways. Do you understand? Is everyone understanding this? Okay, great. Now, standard deviation. What is the standard deviation? It is exactly the same that we have seen before. So, we have the sum of the squares. Yes, the sum of the squares, which is equal to the sum of x1 minus x squared, which is inside there. Yes, multiplied by what? By 1 divided by n, means 1. Why 1 divided by n? Because what I do is I take the deviation, yes, the sum of the squares, the overall deviation for the whole matrix, for the whole thing. And then I compute what is the path of that deviation for each one of the individuals in my sample. Do you understand? Let's focus on this thing. It is very easy. So, what is the measure of error that we have? SS, right? Sum of squares. Sum of squares is this. Do you see this in your mind? If you close the eyes, do you understand this? Okay. Sorry. Here, it is this distance. That's the error. That's what we get. And we make the summatory of all of them. If I make the summatory of all these things, I will get the sum, adding all these things together for the whole array. But now, if you ask me, and what is the typical deviation, right? I will need to divide this by n. Yes? Now we get no, perfect. And why I have a minimum one? Because it is for the sample. And if the sample is very small, I'm going to put a penalty. And the penalty is going to be very high if I only have 2 individuals in my sample, and very small if I have 2 million. So -1 is the sample penalty, the penalty for small samples. Yes.
That one is the one that we. Well,
Which one?
we. Because we think.
It's for each eye in this. Oh,
Yeah, for example, we take one of them and we.
yes, each one of them, exactly, as we have done before. And then we do this human body of thinking, because we need to put all together, and we calculate what is the deviation that I can assign to each as well, or to each of my individuals in my sample. Yeah? Okay, and this is a very nice number already. And it is called variance. It is the variance. The problem that we have is that the variance is not in the same order of magnitude as the mean, because the mean, it is not a square. So I square it so that I can have it in the same order of magnitude of the mean. Do you, everyone? This is the standard deviation. And the square, as I told you, is just because if I don't have it, what? Sorry? Without the square is the variance, and with the is the and well, yeah. I mean, it is not the same thing, because let's say this is when the things start to make sense now. Probably. I mean, like let's say that we have you telling me, like, Javier, in the course of Introduction to Artificial Intelligence, if we measure the age of the students, we have a mean equal to 20 and a variance of 360. And we say, okay, thank you. How do I interpret this variance? 360? 360 is the accumulative, like this for the squares, because they are not on the same order of magnitude. Because we have put all these squares here inside. If there is one person that is 65 years old, he's just, like having here a very high impact because it has a square. So what I'm asking, I will be asking you, can you please tell me what is the standard deviation of 360 or the root of 360? Can you tell me? Make it. $19. And then you tell me you have a standard deviation of 90. I will say, okay, so I expect to have students that are 20 years old with a deviation of 19 years, which is still a lot. So I will be asking you, how many people did you ask? And then you tell me 3. One was 20, and the other 2, they were 70 or 70 years old. And say, okay, can you please ask more people? Like, because it makes no sense. And what happens a lot to me talking with computer scientists is that they give me this thing. They say, that makes no sense. What have you been calculating here? Because they know how to code, but they don't understand the numbers. So this is what we have to make clear here now, that you understand the numbers that you are calculating. This is why I'm consuming so much time. Do you understand the idea? So if the standard deviation it is very low, it will tell me that my expected value this one here, one standard deviation and one standard deviation, most of the data will be here. But if you provide me with something like this, and the standard deviation, it is here and here, and the standard deviation is too high, probably we have a problem of measurement. Probably we have a problem of measurement that we don't have enough data points, and so on. Do you understand? Everyone is understanding the standard deviation? Perfect. Now, again, the variance for three different distributions. So values are different. In the first one, there is a lot of variance, but the mean is still always the same. On the second one, the variance is very low, almost nothing, but the mean is still the same. And on the third one, there is no variance. All the values they have are the same, so all the individuals are the same. Mean usually remains the same. Variance is going to be the thing that is going to be moving. Yeah, so this is the formula. So you have the variance, which can be represented as sigma squared, because it's the square of the sigma. And the standard, and because the sigma is the standard deviation. This is the root. The variance of x is the expected value of the error of the sum of all of them. If x is a variable, that would be that. Yes? Now, if you have ordinal data, you cannot calculate the standard deviation because you don't know what is the distance. The error. You need the concept of distance. Yes? The sum of squares, the goodness of it. The things that tell us how good are we estimating or we are not estimating a specific statistic. If we have interval data, I can calculate it because I know what is the distance between one point and the next one. Yes? Perfect. So, still have time for something. Andreas, for me? Okay. What we usually are going to be doing is plot the data first in order to see things on the data. And we are going to be combining for each one of the groups, for all the classes that we are generating, for the ways in which we are exploring the data, we are going to be generating all these statistics, basic statistics, which are the ones that are going to be allow us to understand the structure of the data set. What we have here is just some of the things that we are going to do during the next days. We are going to be plotting these things by ourselves in R. Exploratory data analysis, as I told you before, is the first step, okay, to do these things. So we need to find out what is the mean, what is the standard deviation, why the data it is so skewed, why the data is so good, how do I have to transform the data? Do I have rational data? Do I have discrete? Is an ordinal scale? Can I do this thing? Can I do the other thing? Do you understand? This is the exploratory data analysis. And it is not like everything in life. It is not something that I'm giving you a book or something like this, and then you have to apply the same thing all the time. It is based on the idea that you are a researcher. You are an expert with a toolbox. And then you open your toolbox, you start to look into the data, modifying the data all the time to see what is going on. So there is not a set of rules like you plot first this thing and then you plot second this other thing. The exploratory data analysis is the concept, the idea of getting into the data, and this is what we call when we are working like get dirty. I'm getting dirty. Like I'm coding, I'm looking, I'm, like this for 25 hours in one day. This is the idea. Because it is not something like someone is telling you, and this is the code translated from Python to C++. No, by looking into the data, you are making research questions. You are looking into different hypotheses. You are looking to the reality from different perspectives. What is the idea of exploratory data analysis? The most basic idea is that you have the one area that you are plotting, and it represents something for you that you understand. Yes? Like when we are talking into, you're plotting means, you need to know what the mean is. You're plotting a linear regression model, you need to understand what the linear regression model is. You plot a correlation plot, then you have to know what the correlation plot is. Because if not, it doesn't make sense for you and for anyone else. So we can plot these kind of things. We can go from a frequency table, like the ones that we have done before, to the histogram. And you already know that you can modify the histogram breaks based on gens, for example, or you can use equal number, or you can use the standard deviation, or you can use the quantity, or you can use whatever you want. And this histogram will be modified, but the data set, it is not going to be modified until you decide to modify it or not. So specific graphs, they tell you different kinds of histories. If we have a box plot, in the box plot, what we see are the outliers, the whiskey, which is the upper whisker end, and the lower whisker end, which is calculated, as you can see here, as the difference or the add of the third quartile or the first quartile plus minus the interquartile range, which is the size of the one quartile and the third quartile. And it's a measurement to see, okay, at which point should we classify a data point as an outlier? Well, the box plot is helping us. It is providing us what is the median, so the value that it is in the middle, not the mean, not the average, the value that it's in the middle. Do you remember that? And now it is telling us the Q3, the quartile number 3. So at 25% of the data, it is between the median and the Q3. 25% of the data, it's between the median and the Q1. Then we have another part of the data which is between Q1 and the lower whiskey, or until the end of the graph. And we have another part of the data which is the top 25%, which is between the Q3 and the last of or outliers. Yeah. So you know this, right? Perfect. So then for next week, you draw a box plot based on this data. I will upload the slide so you can look into the slide, but if you want to make a photograph and make like fast, it is also fine. Next week, the course is going to be online. Next week, you need to have a computer, laptop with, the rest will be with mic and camera. And we will be installing a software which is called R. We will do that together. And we will be installing another software which is built on R, which is an interface to R, a user interface, similar to a Spider in Python, but this is called R Studio. And we are going to be doing these things on R Studio. You can be wherever you want. I will be at home.
Can I ask one question? Can you hear me? Can I ask one question?
Hi, Rao, do you have a question?
Yes, I have a question. Like, I am studying.
I
Like,
cannot hear you. Can you repeat?
okay. Can you hear me? Hello, can you hear me?
I cannot hear you. I'm very sorry. I don't know.
Okay. Can you hear me now?
Let's see. Let me.
Can you hear me now? Hello. Hello.
Let's see if I can do something. Can you try now, Rao?
Can you hear me now?
Yes. Oh, now I can hear you. Yeah.
Okay. As you know, I am studying I am studying online. So I have some questions that I wanna ask to you. So is there any way that I can come to your office or somewhere so that I can
Yes. Yes.
read?
Send me, please. Maybe you have done it already, but send me an email.
Mhm.
I can provide you tomorrow. Maybe we can have a half an hour
Okay.
talk during the morning or during the afternoon. I have to check my calendar.
Okay. I also need to check my schedule because I have classes tomorrow.
Okay, then give me two opportunities, one for tomorrow and one for the day after.
Okay. Okay. I will try to come. I think maybe tomorrow. Maybe I will
No,
not
it
go
will be
to that class.
it will be online because I have a workshops with projects
So the time you will give will be online.
on Teams. Yes, you have an account in Teams
Mhm.
from the university, right?
Can you repeat again?
If you have an MS Teams account,
I don't know this. No, I don't
okay,
have.
but you have Zoom, yeah? I will send you then
Yes.
a Zoom invite.
Okay.
Fine.
Okay. Okay. Thank you so much.
No problem.
Okay. Thank you.
Any other question?
No, no. Just I wanted to ask about this.
No problem. Then thank you very much. Have a nice
You too. You too.
evening
Thank you.
or morning
You
or afternoon.
too. Thank you. Night.